we, Alex and me, and we're XTechnology. Yeah, we're the group of people that enjoys learning new knowledge about IT and also sharing stuff that we already know. We run projects sometimes we do workshops. That's Alex mostly. And sometimes we do this so-called code hours, which is here today. So the concept is that we have 1 hour and we will discuss one topic, or we will show some code, or we will do some explorations. And we'll try to keep it in an hour. And today the topic of our code hour is software system design interview. So it's episode 2. Last week we tried it with the same setup, I would say. So Alex gave me a task and I tried to solve it. And honestly, last week was a disaster. So hopefully this week might be a bit better from my side. I mean,
seriously think it was a disaster? Okay.
yeah, I mean, from my side, yeah, morning. I think I
it was not that
failed to
bad.
design.
No.
Well, thanks.
Uh-huh.
Yeah.
Yeah. Hi. Thanks, Igor, for your introduction. What can I say? Just to add a few things, I think this week is a bit outstanding. We did a event yesterday, Igor. You were there, right?
Yeah. And Alexei presented his work. Yeah.
Nice. Yeah, moving forward with that. And today indeed we continue with this design session and service design. I had 2 questions regarding not the home design, but I mean, did you do some retrospective on a previous step, like what was your thoughts from the last time, and what did you want to improve, and maybe what steps have you done for the next round?
Yeah, thanks for asking, actually. Yeah, I mean, I did a bit of homework. I mostly watched and read the other people doing similar tasks. And first of all, I think what I did not really correctly, I tried to design a feature in the system which is not the main feature, let's say. Because when people say Google Maps, I guess most people use Google Maps to know how to get from point A to point B. So basically to create a route. And I was somehow focusing on rendering the map, which goes from the name of the Google Maps. But first of all, this is probably not a very interesting task. And as I'm not being a software engineer, I cannot say a lot about rendering the map, just super basic things. And I think I should have gone into this direction of defining the route from point A to point B. So first of all, there are like a bit more moving things, and I could say a bit more about it. And also, I think I kind of realize how it could be implemented in terms of algorithms. I mean, not precisely, but just I could talk about it a bit more. And then it would be easier to cover other topics like databases, or I don't know, to count the amount of users. It will be a bit meaningful, kind of how many users trying to find the route from point A to point B. And so, yeah, so I think I was not really doing well on the very first part when I was putting the functional requirements. So, and then it went a bit, yeah. So,
Well, let's see. That's I'm really curious how it will go, and what you think you should be focusing on. So that's actually was my second question. Like considering we're gonna do a next exercise right now, what do you think you'd like to focus the most today?
I mean, that's really my second system design interview, so I never did it before, only that time and this time. So I guess it's interesting for me just to have a brief overview of the whole solution, and then maybe dive deeper into the parts that I might be a bit more familiar with. So if there's anything connected with data or analytics or algorithms which are not super heavy, then I think it's the way for me to go, because there I could at least elaborate a bit more and not
Right.
on these load balancers and
Mm-hmm,
So,
mm-hmm. Okay, yeah, but from my side, I did not do any preparations myself. I just
mhm,
yeah, I have two big application systems to design to propose.
yeah,
So you have a little bit of choice, I think, today.
mhm,
Um, yeah, first one. Yeah, interested in what you're gonna choose from those. Well, first go into the big products again. So it's gonna be a bigger system as well today. Well, first proposal is to design something like YouTube Music or like
mhm,
iTunes kind of systems, so music systems with all
yeah,
kind of albums and yeah, you know it better actually. Well, we know it a good,
yeah.
I
We
think enough.
we use them. Mhm,
Yeah, yeah, and the second one is also a well-known system. It's somehow a LinkedIn, but we can also choose which part we want to focus on. So it can be like a CVs, more like a hiring part, or that could
mhm,
be a social part when the people can connect to each other and yeah, see some activities, things like that.
mhm.
Um, yeah, that's high level. Hmm.
Yeah, cool tasks, both of them. I'm thinking so. First, the first one will is a bit closer to me that because I could say a bit about the algorithms of how the playlists and so on are created. The second one will need a lot of things about, I don't know, like consistency of the messages, like how to keep them up to date from one user to another. I'm not that great in this part, so I would go with the first one. So if I have a choice, yeah. I mean they both
That's cool.
are large, so
Yeah,
yeah.
they both are large. Yeah, what I was thinking, I actually thought I would choose myself maybe a second one. It's like a more clear, but actually I'm not sure about it myself. So
Mhm.
before you start drawing or whatever or typing,
Yeah.
one more question. Do you want some more details on what we want to achieve, or like last time you're gonna yeah, basically do it yourself?
No, of course, I would like to have a bit more details. I don't know if you want to start, or I could start and ask you if it's okay.
Yeah, yeah, would be great. Yeah. Hmm.
Hmm. Yeah, so basically, let's and functional. So first of all, yeah, so we want to build an app which allows the customers to listen to the music in general. So I guess we can focus maybe in music, not on podcasts, not on radio stations, and so on. So there is some storage of music, and customers can log into the system, create their own playlists, and basically listen to these playlists. I know they can also use search engine, I guess, and look for artists and tracks. And when they find it, they should be able to play the material, so the songs. So what else should be in there? So I guess we shouldn't cover the parts about, I don't know, messaging to each other, or yeah, I mean also you can put your what's called feedback, so like or dislike. Maybe we could briefly cover it. Um, so do I miss something big or anything?
Not big. I was having in mind also, ability to share some playlists, so
Mm.
accessing by URLs some resources.
Yeah, that's nice. So
I mean,
actually,
it's
I
crucial that we use also a lot between us, right?
yeah, totally.
Hmm.
So maybe I should already start writing it. Okay, so functional requirements. Um, yeah, I don't want to put a requirement to be able to log in because I'm not sure how to implement it. Well, okay. Users could log in. Search for the music, artists, songs, create playlists, share playlists, I guess, right? We can focus on this.
Yeah, yeah. Well, not
Mhm.
focus, but I would
I
say it's
mean, yeah.
interesting functionality. Yeah.
Hmm. And play the music, I guess.
Mm-hmm.
Maybe like additional add lights to the tracks. Mm, what else do I do when I go to YouTube Music?
Well, lots of stuff that we know, of course, but we also want to skip some functionality, I guess.
Yeah, it would be nice to skip it. Right.
What I miss, well, they have it actually, but I miss really good feedback on some reports from the users. But I don't want if we want to also add it to the requirements.
You mean reports on tracks or on albums?
Um, no, like technical reports from a user perspective, and then the team responds with some,
Ah,
like
oh,
mhm.
yeah, kind of
Yeah, support
feedback.
basically. Hmm.
Uh, service support. Yeah. Okay. Cool. Yeah. Functional. I mean, yeah, non-functional because if there's functional, there should be non-functional. But I think they're usually kind of the same, right? So highly available or so because I mean you want to listen to the music now, you don't want to wait even for 10 seconds, I guess, when you start the playback. And also when you do the search, yes, you would like to have the results as fast as possible. That's actually another one. Latency. And highly available means, yeah, that if you want to listen to the music and you go there and it's not available, the website, then probably you switch to Spotify or some other. Low latency, yeah, so not waiting. What non-functional else? I mean, non-functional
Functional or
requirement.
non-functional? Hmm. Yeah, I was having in mind that to add maybe like we definitely will need some platform to that provide us this music originally, but I
Uh,
don't want to if we want to cover that maybe.
yeah, definitely. We're saying so, like music library
Mm.
in some ways. So yeah, we need to have a lot of music so that our customers could stick to us. Yeah, I'm not sure if I can somehow design this music library or the sources where we get it. But yeah, so amount of music, how fast we search for it and listen, how available the service is. So about this consistency things, so when you kind of created a playlist on your side, you want to share it right away, or there could be some small delay. I guess if even if there's like a minute delay, it's not a problem. No. So
No,
I guess
yeah,
it's not like a super high consistency requirement.
yeah, it's not a bank account. I think we don't have
Yeah.
that requirements. Yeah.
Yeah. Yeah. Otherwise, I see that these are the main non-functional ones. So yeah. So what's next? I don't know. I think it makes sense to again try to calculate some numbers. Maybe we'll use them for the future. So uh, I guess yeah, it's nice to know how many daily active users we have. I guess if our service is super popular, it's gonna be like at least tens of millions.
Yeah, I was
Mm.
thinking the same. Hmm.
Mhm. Um, Tens of millions. Then so each user, yeah, I'm thinking how to calculate this stuff. So if user goes there and they do some search, let's say they look for Radiohead and they find the artist and they start playing it. then I guess it's kind of one search result, one request, search request, one search result, and then they can just start listening it. And they listen for it to it sort of like for half an hour, and then they want to switch to something. And so that will be the second search request. So I guess every user could do like around 5 of these requests per day, and like on average, maybe even less. But on average search requests per day per user, 5.
Mm. Yeah, I have another thought. So
Yeah.
you mentioned these playlists. I think that is all related to high level functionality, which is kind of user specific profile. You know, like maybe you have also a library to save it there, not only playlists but indeed albums or tracks or something like that.
Mm-hmm. You mean into the functional ones?
Yeah, possibly. But yeah, also you can skip it.
Yeah, I don't know, like shares, libraries,
Yeah.
or yeah. Mm-hmm. Yeah, let's start from here. Yeah, and so yeah, what other numbers might we need? So how many users, how frequently they use the service? Mm, maybe we somehow need to evaluate the size of the library, but I mean, it's so huge, I don't even know how people store this stuff. So, uh, yeah, I mean, I guess it's worth. Yeah, so I don't know. Let's say we have 1 million tracks. I don't even know. Like, is 1 million? I guess 1 million. It's a lot, right? It's probably more than YouTube Music has. Mm, okay, number of tracks. Let's say up to 1 million. So maybe it's max. And let's say it's 5 MB each on average. Oh, actually, that's not too much, right? I thought it's gonna be more. Yeah. Maybe it's not 55 MB.
It sounds related to like this Google joke tasks, like calculate how many windows are in New York City, something like that.
Yeah. Kind of. Well, let's go with 1 million now. I don't know. Maybe I'm totally wrong, but yeah. So, what else might we need? Mm, bum, 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 bum. Users, how often they query it, what they query. Yeah, I guess numbers estimation. Yeah, I guess nothing comes to my mind for now. Maybe we could come back to it later. Yeah, so I think now is the time to try to draw a high-level schema of the service, and or at least I try. So yeah, on our side, on left side will be the user. What the user, yeah, I mean there could be a couple of scenarios, right? So what users do, they log in. I don't know, we'll create some authentication service, which I don't want to cover, but authentication service. So they go there, and after it, they are able to communicate with the music service, and they can search for something. They can, yeah, for let's say, yeah, if you go there first, you search music service, perfectly aligned in the center. Okay. a couple of things. So here will be, can I write something in here? No, I cannot. Perfect. Search request. Search request, then there should be some subservice. I don't know, let's call it search service. Search service. Oops. So the search service gives processes the search request and gives us the output. Search result. And to me now it looks super stupid. That, well, you put the request, you get back the result, but I guess that's what I'm supposed to do in here.
Yeah, all done.
Yeah, all done. Yeah, okay. So, and yeah, maybe we can do something like this. Search request, search result. Oops, no, this one. Yeah. So that's one of the scenarios. Another one will be playing the music. Search result. So we pick what we want to play. We click play. Then there should be some other service. I don't know, playback service. It's something what really exists. Again, perfectly aligned.
If you don't mind right now, so I actually the way that you design it already in services. I was wondering where did you get this approach from? I mean, is it something natural coming to your mind, or I would also suppose that it's possible just to say, okay, we have a monolith, it's doing that and that, right? But nowadays, services approach sounds a better one, actually.
Yeah, I was Googling how people implemented this Google Maps or did the system design of Google Maps, and I found some articles they create like 8 or 9 services, not create, specify, like service to create the route, service to update the route, service to re-update, and so on and so forth. So but maybe it's a bit more visual, at least for the system design stuff.
Yeah.
And yeah, it's actually easier for me to say that there is some service which does it. But you never know. Yeah, so if we proceed with this logic, so play request. So we found that out of the service we browsed and we click on one of them. So we send the play request to playback service, and playback service. I don't know. Yeah, it probably you can say that they sent you the file, right? Well, I can just say response. But I guess there will be kind of the file, like the material itself, the MP3 or whatever,
Yeah,
which they send back.
binary
Yeah, and
stream data. Yeah.
yeah. And I mean, of course, there might be some layers of like caching because people are listening to the same music. But for now, we can see that you said binary stream data. Yeah, binary stream data. It sounds awesome.
Yeah. I'm not sure in order. It could be stream binary data as well.
Whatever. It's binary stream data. Okay, yeah, so that's the second thing. And the third thing is regarding this playlists. So we can create some profile service, which will be which will address this. Maybe it can also address lists, playlist, or like request. And by request, I mean that for a like, it's easier. You just click on some button which is accessible in UI and you send this request. But for a playlist, I guess it consists of a couple of search requests and results. And then you combine them in some list and then you send the request, like say this list, something like this. And then, then I guess there's nothing returned back. So just this profile service will update some database, which profile DB. Profile DB. And yeah, and when you do these things, it updates this profile DB, which stores your playlists and your likes. And this DB probably would be used when you do the search. So we might somehow connect it. Sorry for many arrows. So did we cover? So we covered the logging in. Yeah, I didn't cover, but I'm not sure how to exactly search for music, create lists, share playlists. Yeah, I guess for sharing a playlist, at the moment that we create a playlist, we can create some URL for it.
Mm-hmm.
Yeah, and then we should be able to retrieve it from the database.
Yeah, I mean, it all makes sense what you're describing. So you have this authentication service from where all the arrows are coming from. That's probably not what you wanted to have, but
yeah. So I guess there should be some authentication service, and oops, yeah, this thing, the arrows are attached. So I guess after the authentication service, there should be some load balancer, I guess, or something like this, which will send you to one of the copies of all of these services. Because I guess this block should exist in multiple copies, replicas, to make it more scalable. And this authentication service probably as well, but let's say it's only one, and then after you authenticate it, it should via some load balancer send you to one of the replicas of these guys. Yeah, I'm not sure how to draw it nicely now. So I'll be in here. Oh no, it's so hard. Well, I can move a user, I can move an authentication service. This one goes in here. Yeah, no, sorry for wasting the time. Just like this. So load balancer. User goes in here. So yeah, basically all the arrows should go to this load balancer. Yeah, actually, maybe there are some more services in between which I'm missing. Because load balancer just, it shouldn't probably receive back the requests, right? Oh, come on. Yeah. So because so I sent some, I authenticate, then I sent some search result. Search result actually should go from the user, right? Yeah, I don't know how to draw it properly. So I send some search result, it goes to load balancer, it picks one of the replicas. Replicas. This. Oh no, okay. And then it sends it back again through load balancer or directly to me. I don't know how it works, honestly. Let's say this will be enough for now, for a high-level schema. Yeah, so I guess it's okay for the start of what we have in general in the service. And now it probably makes sense to go deeper into some of the services and to the DB. Maybe we could start from a DB, just briefly mention what structure it might have. got profile DB. Okay, yeah, it's aligned. Yeah, just to name the columns of which it should have, like some user ID, of course. And for the user, we should store. Yeah, it's a lot to store. So, yeah, I guess we will need a couple of different tables. So yeah, okay, let's create maybe tables. Table listen history. Table playlists. Table likes. What else might we need? So what we listened to, what playlist we created, what likes we posted. Yeah, maybe for now it's okay. And then just going through them specifically. So listen history should have something like user ID. Then I guess the track ID. So yeah, let's say we should have some other table which has information about track ID, all of its properties like artists, name, year, style, and so on. So it's probably going to be not a profile DB, but yeah, we'll throw it in here. Data DB, and it should be somehow connected to. Yeah, I think it should be connected in the direction from the search service because we're gonna search in this data DB, and the result, yeah, will also go in here, and probably to our playback service to show the titles and so on. Too many arrows. Okay, so this listen history will have like the user track that you listen to, timestamp, and some, I don't know, like start timestamp and stop timestamp. Yeah, I guess it should be enough for now. Yeah, like playlist again, ID, then playlist ID. Maybe URL which you should be able to share of this playlist. Yeah, I guess that should be enough. And yeah, of course, there should be another table which will have like the playlist ID and the list of tracks which will it have. Maybe it could be also another table in here. Yeah. Playlist metadata. So yeah, playlist ID and track ID. So now we should be able to build the playlist. And the likes, yeah. Likes DB. Yeah, so user ID, track ID, and like flag, or it could be not only like, but maybe dislike, so we can say that it's a flag. I don't know, 0, 1, 2, 3, 4, 5, something. Yeah, so I think, yeah, that's it for the structure of the DBs. And maybe we can say some things about like how people will use this DB. So in terms of like, will they write more or read more from this DB? So let's say the profile DB listen history. I guess this will be, yeah, I think it's kind of equal in terms of reading and writing because we update it every, let's say, 5 minutes when every track is when we listen to the new track, and we retrieve it. We read it every, let's say, 30 minutes when we want to have the new search result. But I guess it's more or less equal in terms of read writing. Yeah, okay, it's more heavy read. Yeah, and as I heard in these cases, you kind of create, or one of the ways is to go is to create a master copy of this database, which will be used for. Oh wait, that's another use case. That's the opposite use case. So yeah, we need to write only once an hour, let's say, and to read every 5 minutes. No, wait, I'm confused. Sorry, we need to write every 5 minutes, and we need to read only once in an hour. Yeah, I guess the concept could be the same, that you have a master database and a couple of how you call it? Slave is a bad word now, right? Secondary databases. Yeah, which are synced with the master from time to time. And so it won't be like super consistent. So when we listen to another track, so this might be updated maybe in a couple of minutes. Although I think Spotify does it like super fast, but let's say we can do it in a couple of minutes. So yeah, let's say when we listen to something, this record goes to one of the secondary databases, and then in some, I don't know, in every second minute or every fifth minute, this information should be merged into the master database, which probably already, yeah, well, let's say it is. Yeah, and every hour, let's say, we request this master database and try to get something from it. Yeah, I'm not sure if I'm doing okay. Okay, so this one is kind of updated every 5 minutes, read every hour. So listen history, it's updated every like 5 minutes, but it's read. Yeah, it's I guess also like every other hour when we want to search for something new. So listen. Oh, I have listen history twice. So let's playlist data. For playlist data, yeah, it's updated quite rarely. So when a user creates some playlist, so let's say once a day, and it's read probably even. Yeah, then it's so it's updated kind of once. So you create it only once, and then you listen to it, let's say once in a week. So not so heavy. Metadata, yeah, it's also the same kind of. And likes DB, yeah, you can. Yeah, I think all of the tables are updated kind of once in 5 minutes and read once in an hour, or even.
A little question on the structure still. So for playlists, do you think the order of tracks, saving tracks matters? And
Yeah,
maybe
you're right.
timestamps as well?
Yeah, you're right. So track ID and some um, track order. Yeah, it definitely matters. Okay. Okay. Yeah, I'm not sure if it makes sense to draw this structure of master DB and secondary DBs. I just maybe we can do something like I don't know, master DB gets the data from secondary every 5 minutes. And then there are a couple of secondary ones. Secondary. No. Oh yeah, I was just about to connect this master DB to some service which calculates the user profile. Yeah, okay. Let me just delete all of it. It's not worth going in here. What I wanted to cover. So I probably wanted to dive deeper into some of the services: search service, playback service, profile service, and I think search service might be interesting, but also there should be some service which creates kind of the user music profiles. So I call it here profile service. And in here it says just what we listen to and what we like to, but there should be some service which calculates our preferences. So let's maybe draw it in here. Let's call it recommendation service. Recommender service. And so this recommender service gets the data from profile DB and also from metadata DB. Yeah, and then actually it could be even probably out of this replicas. It could be maybe one service which runs somewhere on the separate instance or whatever you call it. So you don't have to replicate it a lot. And it runs some, yeah, I mean, this is a part which I'm kind of familiar with because I'm a data scientist. And so this service gets as an input all that the customer listened to and their preferences, and it outputs the recommendations for the search results. And also, yeah, I guess in here we only have a search result. So basically, if you type in, I don't know, rock music, so the result should be different based on your previous history. So yeah, so maybe we can create like another layer in here, personal preferences service. But I guess that we can maybe say that in search service you can type for like looking for an artist you want, or you can look just for the recommendations that this recommender service provided to you. So let me draw this line to search service. So let's say in the search service there is some small area where recommendations are. And yeah, so I can focus on this recommender service, how it might work. Do you think it's okay, or we should cover?
I think it makes sense because you said you are familiar with that. I think it would be really nice to cover that. Yeah.
Okay. Yeah. So in most of the cases, these recommender services are implemented in a so-called multi-stage way. So multi-stage approach. So when if you want to be recommended something, on the initial stage we have this 1 million tracks and 1 million candidates, and the first stage is dedicated to shrink this 1 million to something more workable. So let's say 10,000. And because it's not and it should be super fast, and it should do it not randomly but also based on some information that we already have. And the easiest way to go is to use a so-called collaborative filtering approach. That means that we build a huge, we have a history of what people have listened to before. We build a huge matrix out of it. Build user item matrix. So like the rows will be our users and the items will be all our tracks, and then in the matrix itself will be like zeros and ones if the customers have listened to it or not. And then we apply some factorization techniques, like we split this matrix into two smaller matrices. Factorize the matrix and get two smaller matrices, which we will call also embeddings. So after this factorization, we will have two smaller matrices, and one matrix will represent our users, and every user will have an embedding, so basically a vector of the length k, which we specify. It could be like 20. And that means that before we had a huge matrix, like amount of users times amount of tracks, and now we have just an embedding of the size 20 for every user and every song as well. And now, and they all belong to the same vector space, and that means that we can compare them to each other. And that means that we can get the vector for the user that we are currently looking at, and then search for this closest vectors of items to this user. And this operation is quite heavy because for one user we have like still 100 million of 1 million candidates, but there are some techniques that I don't know called approximate. How it's called?
I remember something.
Yeah, so I mean, you basically can iterate through all of them, and then it's all begin, which is not really cool. But you can do like approximate nearest neighbors. Of course, and it will act a bit more efficient. It won't find the perfect results for you, but it will find approximate results which are mostly good enough for you. So, and this so these embeddings should be pre-calculated before we do the search. So let's say it runs every 5 hours. And then on the search request, we retrieve the embeddings of the user. We quickly apply this A&M, and we get the 10K of our tracks. So now we have the second stage, and on this stage we can apply already a bit more complicated ML techniques. So let's say call it heavier ML model. So here the idea is that we have 10,000 tracks, and we can already get all the features that are available for these tracks and also for the user. So it could be like, I don't know, thousands of features, and we can throw them all to one model, and then this model will infer or predict the results for this user and all these 1,000 tracks. And as long as it should be much faster, because we already deal with only 10K users, should be faster. And might have, I don't know, 1K features. User plus tracks plus some context. By context, I mean what time is it, what day or season, because it might all affect the results. And basically, the output will be sort order of these 10K tracks. So we will output some value which we will use for sorting these 10,000 tracks. And basically, in the end, maybe there will be some other stage, like business logic stage. Let's say we order this 10K and we get the top 20. Oh, okay, top 50. Top 50 predictions. And now we apply some rules on top of them, because it might be that out of these top 50 predictions, there will be some, I don't know, tracks of the same artists, which the same track of the same artist, just with different names because some issues in the database, or it could be some original track and then some radio edit track and some remix. So we don't want to output all this to the customer. So yeah, I apply some hard-coded logic based on I would say UX and commercials maybe. I don't know what commercials. Maybe you don't want to. Maybe some of the artist is paying more for the search results to get on top, and you wanted to prioritize him higher. I don't know if it's the case, but what if? And so you kind of reshuffle this top 50, and in the end, output resorted and refiltered list of 50. Maybe it will be already 40 or 30. Yeah, so basically, usually these three major layers. The first one is something fast, which is easy to calculate, and it also uses pre-calculation, like a batch approach. And the second is heavy machine learning model, which is calculated online, but the feature for this model, so these ones are also pre-calculated on a batch basis. So in live, we have the service which retrieves these features and runs the model itself. That will be live. And then these rules are also live, but they should be super lightweight. Yeah, so in the end, we have this list. So it could be the search result for us, or also it could be the recommendation for playlists for the customer, or it could be a recommendation for the set of tracks or a set of artists. Because in this, on the first stage, user item metrics, we can use, for example, user playlist metrics or user artist metrics or user radio station metrics. And in the end, we can do the same. So given the embedding of the user, we can find the closest embeddings of whatever users, or users as well, items, track lists, whatever we might need. Yeah, so, but I guess it's more like ML system design. It's not the case. I think that should be it about this recommender service. I feel that I'm kind of missing of saying something regarding the hardware, like what we might need for it, or which software services in terms of, I don't know, is caching or whatever. For this. So I'm trying to think of where to start from.
Yeah.
So maybe, yeah, okay, maybe we could say a couple of words regarding caching. Because, so again, when customers are putting a search request, most definitely they will look for something popular or based on the country, of course. So these load balancers, they will send us to these replicas, and these replicas will exist, let's say, in every country, at least where we operate. Not only in terms of the load of the service, but also in terms of the different data which might be contained, because the metadata and the profile DB will be different for different countries, and the music as well. Yeah, actually, we don't have a music DB. Who do we? No, we don't. Yeah, so basically, in every country, there's a separate set of tracks that are available for the customers. And what did I want to say? Yeah, so basically, when people search for something, they search probably for popular things, and this binary stream data, which we output here from the playback service, it should be I think like heavily cached, so because people will listen to the same stuff again and again, and I think it's again cached with this CDNs, cloud delivery
Mhm.
networks. So it's somewhere on the site which is much closer to, to the customer. They will all listen with lower latency.
Mhm.
Also, this search service probably should have some cache because if people look for the same stuff, just put the name of the artist, the result should be already retrieved from the cache, not calculated. Uh, yeah. Mm, okay. This I at least touched.
Yeah, that's
Yeah, and yeah, and again, so regarding the hardware, uh, so DB, I don't know. So yeah, we have 10 million users. They do 5 requests per day, so that makes us 50 million requests per day, and this will add. So let's calculate maybe the size of the history that we have to track. Um, User activity history. So 50 million events per day. Every event will have, yeah, every event will be oops, the playlist data. Oh no, the history. Where is the history? Yeah, this one. So every event will have the size, I don't know, of 10 tracks, and every row in this table, yeah, it's quite a small table, but let's say maybe 1 kilobyte should be enough for all these IDs, like 2 IDs plus 2 timestamps. I guess it should be more than enough. Mm, times 1 kilobyte times 10 tracks, which is probably too much. So again, we multiply, like, what's the size that we need? Uh,
Mhm.
1 kilobyte times 50 million, that's already mega giga tera, right? So 50 terabytes, and times 10, 500 terabytes for per day. Wow, was it correct? I think it was. Yeah, so that means that every day we will write to this profile DB at least. So this no wait, this listen history. So okay, this one will be much smaller because it's only. Ah, wait, it's not a table. Okay, so this table is not calculated right now. This table, it's only for playlists. It's kind of smaller, but also have to be calculated. This one probably also smaller. Sometimes we not often put the likes, and at least, yeah, this will be also high connected to this one. So we can say that maybe it also is 500 terabytes. So at least we have times 2 tables like this. So that means that what goes after tera peta, right? I
Mm.
guess. Yeah, I'm not sure. So
Yeah.
1 petabyte per day of the new data, and that's huge. So actually, this profile DB should be a really big one. So I think you cannot. There are no machines which can store 1 petabyte. So we didn't shard them from for different countries, right? Because it definitely makes sense to have different profile DBs for different countries. And let's say here we have not a million, but not not 100 million, but maybe 1 million on average times 5 events. That will be okay. Yeah, point 1 petabyte, whatever. Yeah, I guess I just reverted back.
Mhm.
So again, we need to have some DB system or cluster which can store
Mm-hmm.
the history for, let's say, last 3 months or half a year. It will be
Mm-hmm.
already what goes after peta. It would be like dozens of petabytes, let's say, or 100 petabytes, which is huge. And
Yeah,
yeah, I know that our time is up, so you can just
exactly.
stop me anytime.
Yeah, it's good. I think indeed we should maybe wrap it up a little. I just have
Mhm.
one question for like if you look at this model that you built today, how would you estimate consistency or what is missing? One point or yeah, just a few points about it.
The consistency.
Oh, not necessary, but for example, consistency. Like yeah, what this model is missing. What would you like to
Hmm.
think of next?
Yeah, I mean, first of all, it misses some clear structure because it was not thought through in the beginning.
Mm-hmm.
So all these arrows, they are confusing. But then I didn't think really how the user is connected to this to this service. So now I said there's some authentication service and some load balancer and then some directly a lot of replicas of this stuff.
Mm-hmm.
I I think it should be done in a smarter way, although I don't know how yet. Now.
Mm-hmm.
Yeah, then I should probably mention that this replica exists per region. And I mean, there are different regions which contain even different data. So, yeah, we can actually probably create kind of two sets out of it. So one will be this one. So the services, and these services can exist just based on the load. And
Mm-hmm.
another entity will be like the data that we have, and the data like this, and the data should be split by regions because and yeah, and in all the regions it should also be replicated based on the amount of on the amount of users that this region might have. So kind
Mm-hmm.
of split the computational stuff and the data stuff. Mm,
Yeah. Okay. Yeah, well, Igor, thanks for this exercise. Was again very helping, I think.
yeah,
Yeah.
thanks a lot for guiding. I
Mm.
think I'm probably getting better, yes, but this level is yet very basic, I would say. Uh,
Yeah, we need to
let's
continue
see.
exercise or trying it. Yeah.
Yeah,
So yeah, I think it's a good moment to stop it. And thanks everyone for watching, joining us today. Next week is gonna be something else probably. So
yeah,
follow our channels and stay tuned.
yeah. Have a great Sunday, guys. See ya.
Bye bye.
Thanks for watching.